How diddly 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 diddly. How do you do? This is the fifth and final video for the January 2017 Algebra 2 Common Core exam. We will cover questions 32 through, let's say 37, because that's a good spot to end. Because it's the last problem in the exam, let's get to it. Problem 32 is a beautiful algebra problem. Given f of x equals 3x squared plus 7x minus 20, and g of x is x minus 2, state the quotient and remainder of f of x minus g of x in the form q of x plus r of x over g of x. First off, I know this tells me I need to divide. Okay, I'm going to be dividing my polynomials here. All right. Second of all, don't freak out over this. This just means quotient. When you divide, you need a quotient. That's your answer. This means remainder. All right? And our remainder always goes over what we were dividing in, which happens to be g of x, which is x minus 2. Okay? So just divide and write it like you normally would or like you should. All right? So I've got to realize I've got to take highlighter f of x and divide that by g of x. The beautiful thing here is I notice that this is 1x plus or minus something, okay? Which means I can use synthetic. So if I take x minus 2 and I solve that, right? If this is like a booty cheek and T-bone situation, I would get x equals positive 2. And that is what I'm going to divide in using synthetic division. Synthetic division tells me I just take the numbers 3, positive 7, and negative 20. Okay? And what I do for synthetic is I drop the first number, and I always multiply and get a product. And that product always gets added to the next number. Meaning, I take my 2 and multiply it times 3. That gives me 6. 7 plus 6 is 13. I take my 2 and multiply it times 13 and get 26. And when I take negative 20 and add 26, I get positive 6. That's my remainder. So what's all this other filth and flarn? Well, this first term have 0 x's. This first term would have x to the 1, and so forth if I were to keep on going. I stop at x to the 1. So, based on how they want me to write my answer here, I have my quotient, which is 3x. It's a positive 13, plus 6. My remainder is positive 6. I put my remainder over what I originally divided in, g of x, which is x minus 2. So that's my remainder's just got to go over x minus 2. And you are done, man. That first one was nice and easy. Love it. You could use reverse tabular. You'd get the same exact answer. All right? But whenever I have an opportunity to use synthetic, I always do. It just seems so much simpler and fluid to me. We now move on to part 3. All right? Answer all questions in this part. Answer all 4 questions. Each question's 4 credits. A correct answer with no work, it's 1 point out of the 4. Again, don't be lazy. Write your work down. If you have to use the calculator and cannot show your work, at least use the calculator to get your 1 point. All right? But don't lose 3 points for being lazy. Number 33. There are 2 ways that I can do this. And since I love synthetic division so much, I'm going to show you that way. I could, if I wanted to, FOIL this in, my x first, then my negative 4, combine like terms where I can, and compare both the left side and right side of my equal sign. But what I'm going to do here instead of multiply, is divide. I'm going to divide both sides by x minus 4. Okay, this goes bye-bye. Okay, which means if I divide this by x minus 4, my answer should be this right here. This should be my quotient, and this should be my remainder. All right? And I think that's what I'm going to do. To me, that seems to be a little bit easier. All right? Now, let's go ahead and say to ourselves, this is 1x plus and minus something, so I am absolutely going to do synthetic division. X minus 4, if that equals 0, x would have to be positive 4. 2, negative 10, positive 11, and negative 7. Okay, I don't know why I put the pluses and minuses there, but you can. Who cares? I drop the deuce. Ha ha. Okay, I'm going to add all my products, right? I'm always going to add these. 4 times 2 is 8. If I take negative 10 and add 8, I get a negative 2. 4 times negative 2 is negative 8. If I add 11 and negative 8, I get a positive 3. And 4 times 3 is 12. Negative 7 plus 12 is a positive 5. This, my friends, is my remainder. And just like the last problem, man, what a couple of great problems to start with. I love synthetic division. It's so easy. This is x to the 0, x to the power of 1, x squared, and so forth. So if I rewrote this, I'd get 2x squared minus 2x. That's a positive 3 plus my remainder of 5 over whatever. But for the conversation's sake, this is what we have right now. This is the division we just did. It should equal this right here. So what I'm going to do is just rewrite that. 2x squared plus hx plus 3 plus k. Did I even read this problem? I just looked at it and realized it was division. Obviously, algebraically determine the values of h and k to correctly complete this identity. What they gave us here to start with, they said it's an identity. It's true. It holds true. So all I'm going to do is just manipulate both sides, which is what I did. And this is what I have right here. They should be the same because it's an identity. They're equal. 2x squared, 2x squared. Okay? Here we go. I have to solve for h. That means whatever this is right here, it should be exactly the same as this. So guess what? My h has to be negative 2. Bam. All right? And furthermore, look at this, is great. I have my plus 3, I have my plus 3. Then I have my plus k. That means this number right here has to be k. K equals 5. That, to me, was a layup for a 4-point question. A 4-point question that just requires you to do synthetic division. I think they didn't expect this to work out this way. I think what they really wanted you to do was FOIL this x first, then distribute this negative 4 next. Okay, then you have all these terms plus a k at the end, whatever this is, instead of equal to this, and then you kind of match the terms up and figure it out that way. And you can do it that way. You absolutely can. But synthetic division, why not? Why not, man? Why not? Okay. Elena has decided to run the Buffalo Half Marathon in May. Good for her. She's got more determination than I do. I would never run a half marathon. I like to exercise, but half marathon. Man, that's grit. She researched training plans on the internet and is looking at 2 possible plans. The first one is Jillian's plan, okay, which is this one in here, these blue dots. Okay. The second plan is Josh's 14-week plan, which is the axis here. It goes up, down, up, down, up, down, up. The number of miles run per week for each plan is plotted below. Okay, here's our miles. We'll call this M. Here's our weeks. We'll call this W. Right? Now, which one of the following plans is an arithmetic pattern? And explain how you arrived at your answer. Great question. Easy question. You just need to know the difference between arithmetic and geometric. Okay? Geometric, arithmetic. Geometric might go 2, 4, 8, 16, and so forth, because geometrics have a common factor. I am multiplying everything by 2. All right? An arithmetic sequence would go 2, 4, 6, 8, and so forth. I am adding, I have a common difference that goes up the same amount every single time. If I look at my geometric one, this one goes up 2, that's nice. But then this one goes up 4. This one goes up 8, and so forth. This is not the same amount every time. That's why it is a common factor. It's multiplication. Going up by the same amount every time is adding. Okay? So if I look at my two plans, specifically I'm looking at my graph here. Which plan is the one that has a common difference? It goes up the same amount every time. It's the straight line. This goes up, then it goes down. Then it goes up even further, then it goes down. Then it goes up. You see what I'm saying? That's not going up then going down. It's not adding the same value every time, okay? This line right here is a nice straight, the slope, it's a line. The slope is the same every single time. So to answer this first question, which one of the plans follows an arithmetic pattern? First, answer this. Okay, Jillian's. Explain. Use my words. How do I know that? Well, I told you I would write it that way. It goes up the same amount every time. It's a line. It has the same slope. So I would just write that. I don't know. It increases by the same amount every time. Boom. Those are words. Good. Look at you using your English. All right. Write a recursive definition to represent the number of miles run each week for the duration of the plan you chose. We chose Jillian's, so I need a recursive definition for Jillian's. All right, plan. First of all, recursive means two things. Number one, you need an M1. You have to be given the very first term. All right? In our instance right here, after the first week, we are running 10 miles. Okay? So M1 is 10. By definition, that's what recursive means. Okay? Well, by definition, that's what recursive means. You need to be given the very first element. Okay? There it is. We know that after week 1, it's 10. Recursive also means you can only find the next term. You find the next term by using the term before it, okay? So what does that mean? That means if I want to find the next term, whatever my W is, because I'm using weeks here, okay? After week 1, if my W is 1, I know it's 10, okay? I need to take my previous term, whatever W is, I subtract 1 from it. And what is the change? Well, to go from 1 to 2 here, I go up from 10 to 11. So I go up 1 and over 1. My slope is 1. So I'm just increasing by 1 every time. So if this is my week, here's my miles. Okay, week 1 was 10. Week 2 is 11. Week 3 is 12. Week 4 is 13, and so forth. I'm literally adding 1 each time. So I take the previous week and I just add 1. Okay, what you have in front of you, by definition, is recursive. You have your starting value, and you find your next value by using your previous one. This is the previous. If I want to find week 2, if my W was 2, I'd put 2 minus 1, which means I need to use M1. I take M1 and add 1 to it, and it would give me the next one. So 10 plus 1 would give me 11 for week 2. That's exactly what we have here, week 2, and so forth. All right? That's recursive. The next part. Jillian's plan has an alternative if Elena wanted the train instead for a full 26-mile marathon. Okay? Week 1 would start with 13. Okay, so this is what I'm going to do. Here's week 1. Here's my miles. It would start with 13. Okay? And follow the same pattern, which means it would go up 1 every time. Okay, I'm just going to keep on adding 1 to all these. Week 4 would be 16 and so forth. All right, I'm still just adding 1. Still just adding 1. Still just adding 1. All right. Now, This would continue for 14 weeks. Write an explicit formula. It's no longer recursive. I just want an equation. Just give me an equation to help me figure this out. Okay? Write it in simplest form to represent the number of miles run each week for the full marathon. So what you could do, okay, you see how you got something +1 here? Okay, I see what's happening here. If I were to, y equals my slope plus my y-intercept, right? This would be a general equation. This is not miles, that's slope right now. All right? So what I would do is this. I'm going to plot these points that I have here in red, if you don't mind. 113, right? So let's do this. Okay, we're going to go here. So at week 1, I'm going to be at 13, which is right in between here. At week 2, I'm going to be at 14. At week 3, I'm going to be at 15. At week 4, I'm going to be at 16, and so forth. So the line would kind of go up parallel, but look where it comes down. Boom. Week 0 is 12. Why is this 12 important? That's the y-intercept, isn't it? My y-intercept would be 12. Plus my slope is still 1, so it's 1x. All right, so in terms of our problem, instead of y, I'm going to use m of w equals, and instead of x, remember this is my x, this is my y, this should be m of w. I'm going to use a w now, so it's going to be 1w plus 12. So let's see if this works. If my week was 1 plus 12 should give me 13, right? Week 1, 13 miles. What if my week was 3? 3 plus 12 should give me 15, right? 3:15. So it works every time. This is your explicit formula. It is an equation. Bam. Oh, 35. Data and stats. Love it. The guidance department has reported that the senior class, 2.3% of members are Key Club. 2.3% are members of Key Club, which we'll call K. Okay. 8.6% are enrolled in AP Physics, which we call P. And, oh, isn't this lovely? 1.9% are in both. Determine the probability of P given K. All right? The probability of P given K, that's what the straight line means. It means given. Okay, is the same as, I'm going to use both. Okay, I'm going to use this. It's the same as saying the probability of P and K all over the probability of just K. All right, that is an equation to determine conditional probability. Conditional probability is given. Given. All right, well, let's put in what we know. The probability of P and K, both, this means and. Okay, P and K is 1.9%. Over the probability of just K, which is the Key Club, is 2.3%. If I divide those two, if I actually do that out, because they want this to the nearest 1/10 of a percent, I take 1.9 and divide it by 2.3. Now, that gives me 0.8260, but they want a percent. This isn't a decimal. To make that a percent, I've got to call that 82.6. They want that rounded to the nearest 1/10 of a percent. If I get 82.608, whatever, this is the 1/10. That will stay 6 because the number after it is less than 5. Bam. That was simple. You had to remember this. If you knew this, it's very, very simple. Okay? Now the next part is even, it's even simpler in my opinion, but let's go. The principal would like a basic interpretation of these results. What does this mean? Okay, write a statement relating your calculated probability to the student enrollment in the given situation. Okay, this 82.6% represents the probability that someone is in AP Physics given they're in Key Club. Now remember what given means. I said given like a million times in the lesson. I don't know, unit 5 maybe. But I forget where that was exactly. But whenever they give you something to pick from, whenever they give you just the Key Club kids, all right, that means we're not picking out of our pool to pick from is no longer the entire population. Our pool to pick from is out of all the kids that were given, which is in Key Club. So I'm going to say 82.6% of all the kids in Key Club, okay, because we are given just this pool to pick from, the Key Club kids. So out of all the Key Club kids, 82.6% are also in AP Physics, which is a heavily related course to mathematics, which I love. So 82.6% of all the kids in Key Club are also in AP Physics. You can write that a million different ways. Out of all the kids in Key Club, 82.6% of them are also in AP Physics, whatever. Anyway, as long as you convey that point, you're good to go. I don't like this problem. I don't like it at all. How come? Because they really talk about a situation that you haven't had experience with yet, and that drives me crazy. Anyways, hopefully you will have experience in this. You won't have to crunch these numbers. If you could, even better. It talks about buying a car and getting a loan for that, okay? Using the formula below, determine the monthly payment on a 5-year car loan. It's important. With a monthly percentage rate of 0.625. Of course, well, let's just move forward before I get ahead of myself. For a car that originally cost $21,000, and you have a $1,000 down payment. Okay, they want that to the nearest cent. Let's put any piece of information where we can. All right. Here's the equation I'm going to use. They tell you P of n is the present amount borrowed. If it costs $21,000 and you put $1,000 down, there's $20,000 left to pay. That's what you're borrowing. Okay? So the amount borrowed is 20 grand. Simple. The number of monthly pay periods. Okay? Well, obviously, monthly is 12 times a year. How many years is this loan? For 5 years. So 12 times 5 is 60. That is the number of pay periods. You have got to make 60 payments over the course of 5 years because there's 12 months a year times your 5 years. Monthly payment. Well, it seems to me, determine the monthly payment. That's what we're trying to figure out here. Okay, this is what we're figuring out. Everything else we should have. And the interest rate. Well, I know I can't use a percent. I've got to slide the decimal. It's 0.00625. 0.00625. All right. This looks intimidating. It is not once you put numbers in, okay? Because it's going to be a heavy calculator problem. Let me get some space here. I'm going to say P of n, which is 20,000, equals my payment. I'm just going to call that P for the sake of not writing as much. Times, so we have this fraction here. 1 minus parenthesis 1 plus my rate, which is I. Okay? I'm on this part here now. 1 minus parenthesis 1 plus the I, which is 0.00625. Okay? That top parenthesis is raised to the negative n, which is the number of monthly payments. So to the negative 60 all over I, which is 0.00625. Now, the first thing I'm going to do, I know I've got to solve for P. So let's figure out what this value is. Let's say it ends up being 20. I don't know what it is. Actually, I do. But let's say this ends up being 20 in parentheses. I'm multiplying P times 20. So how do I solve for P? I just divide by that 20. So whatever that parenthesis value is, I want to find that out first and then divide by it, and I'm done, okay, with the first part. So let's take the calculator. Oh, $343 is what I've spent in copies this year. Look at me. I got to get to 500 quick. On. That last thing was a joke, by the way, but on. There we go. Let's clear this out. let's take a fraction. Now let's do this. We don't really do this that often, but because, you know, we're going to put this fraction in the green parentheses here. And I'm going to say 1 minus parenthesis 1 plus 0.00625. Close that parenthesis out, and I got to raise that to the negative 60. Down here, 0.00625. And I hit enter. 49.905. For the sake of writing down, I'm going to put 49.905. When I actually do the math, I'm going to have to use this whole number, though. I can't get rid of it. I can't round until the very end. For the sake of writing, I'm just going to call that 49.905. So I say 20,000 equals P times 49.905. You see what I did? This whole thing is now replaced. Now it's easy. I just divide both sides by 49.905. Divide this by 49.905. So my P is going to be to the nearest cent. Now keep in mind, when I go back to the calculator, I'm not going to use 49.905. I'm actually going to use this whole number here. So I'm going to take my 20,000 and divide that by this number here. I am not going to round that number. I don't want to round until the end. $400, and if this is money, okay, that 5 will raise up to a 6 because the number after it is 5 or bigger. So it's $400.76. That's what your monthly payments would be for that car. All right, so let's take a look at part 2 of this question, which isn't as bad either, but it's complicated. And what I mean by complicated is the following, all right? The affordable monthly payment is $300. So what they're telling us here is, this is what we want our monthly payment to be. This, I want to be $300 right here, my monthly payment, okay? So the affordable monthly payment is $300 for the same time period. So that's still 5 years, which means that's still 60 pay periods. Determine an appropriate down payment to the nearest dollar, which means in order to get a $300 payment, what should my down payment be? All right. Let's first start gathering all the information we know. I need to figure out how much money do I need to borrow to make my payment $300. So I need to find P of N. I'm just going to call that P of N right here. I know I want my payment to be $300. And look it, I could type all this in again, but the information's the same. I know it's going to be this thing right here, this 49.905. So 49.905. Okay. Now, that's going to tell me how much I would need to borrow to make this 300 happen. Now, here we go. Again, do not use 49.905. Instead, we're going to use this big, long number in the calculator. I'm going to take 300, and I'm going to multiply it times this big number that is not rounded. Boom. Okay? And I'm going to hit enter. So, again, that's about $14,971.59. Okay, that 9 will stay a 9 because the number after it is smaller than 5. So $14,971.59. $14,971.59. This is how much I would need to borrow to make this 300 happen. That doesn't tell me what my down payment needs to be. This helps me figure out the down payment. What does that mean? That means if the car initially cost $21,000, okay, well, I don't want to borrow $21,000. I don't even want to borrow $20,000. I want to borrow, okay, $14,971.59. So what number goes here? This is what they're asking for. So, I don't know, take your $21,000 and subtract $14,971.59. Whatever difference that is, that's the money you need to put down in the car, all right? So let's take, again, we're not rounding, even though we have 59 there. I'm going to take my 21,000, and I'm going to subtract what I need to borrow and realize that I would have to put $6,028.41. Now, this is what sucks. 6028.41, right? Ready? 6048.21, which means I would have to put down $6,048.21 to make it so that I only borrow $14,971 so that I have a $300 payment. You see how they asked for the nearest cent here? For the second problem, they asked the nearest dollar. Shame on them for trying to make this as complicated as humanly possible. $6,048. That 8 would stay an 8 because the number after it is less than 5. Woo! The complication was not in the math. It was in the understanding the process, I feel, for a teenager. Part 4, the final question. Answer the question in this part. A correct answer, 6 points. Again, correct answer with no work, 1 out of 6. Don't be lazy. Be slick if that's the only way you can do it. But if you know your math, don't be lazy. Let's do this poo-poo. Oh, good, an algebra one. The speed of a tidal wave S. S is in hundreds of miles per hour. Can be modeled by the equation S equals the square root of t minus 2t plus 6, where t represents the time from its origin in hours. Algebraically determine the time when S is 0. Okay, ready? S is 0. So I'm going to say 0 equals the square root of t. I'm just going to write this here. Minus 2t plus 6. Right away, what pops in my mind is I have a square root there. I would like to get rid of that using opposite math, which means I have to square the square root. I should probably not square the square root until I get it alone, until it's the only term on its side. So I'm going to get rid of this 2t and this 6. What I do to one side, I have to do to the other. So right now I have 2t minus 6 equals the square root of t. Now I'm going to square both sides. All right? So the 2 and the square root cancel, go bye-bye. I'm going to FOIL this out for you right now. It is 4t squared minus 24t plus 36. That reeks of quadratic. Meaning, in order to solve a quadratic, algebraically, I got to get everything to one side and set it equal to 0. So I'm going to subtract this t, 1t from both sides. Subtract 1t. And I now have 4t squared minus 24t, minus 25t. Look at me just writing and not doing math. 25t plus 36 equals 0. I do something called the slip and slide method, and I've taught this during the year. I slip the 4 out back, and I multiply my last number by 4. So now it's t squared minus 25t plus, if I multiply these, I get 144 equals 0. Okay. Okay. Now, I've got to do the following. I've got to factor that. This might not jump out to you. T. Two things that multiply to be a positive 144 that add to be a negative. That means a negative times a negative would give me a positive. It is 9 and 16. Negative 9 and negative 16 multiply to a positive 144 and add to negative 25. The last thing I need to do in slip and slide is I brought that 4 out with multiplication, right? I can't just leave it. I need to bring it back in with division. So I divide both sides by 4. Okay, so get t minus 9/4. And then I got t minus, this reduces to 4, equals 0. If I t-bone that at this point, I get t equals 9/4 and t equals 4. I know for a fact that 4 will not work. If I tried both of those, if I put a 4 in here, I'd have -8, right? What's -8 plus 6? I would end up with -2. Okay. Oh no, wait, never mind. That might work. We should check both of these answers right now. It's actually going to be the 9/4 that doesn't work. Look at me go. Weird. If I checked both of these, if I put these both in, okay, you'll get an extraneous solution. This one works. This one does not work. Okay? This is an extraneous solution. All right? What that means is, and often the times with any time you have a square root, okay, in an equation you solve for it, you should check your answers. 4 works. 9/4 does not work. Okay, it never will work. All right, so that's an extraneous solution. It looks like it works, it just doesn't. So when they want me to algebraically determine the time when s is 0, the time is 4. So that is going to be 4 hours. That's going to be my answer. All right. Now, this next one, I think is actually really, really easy. It's just they're trying to trick. I mean, for a 6-point question, this you just have an extraneous solution. I mean, I think what's difficult maybe might be trying to factor this, 4t squared minus 25 plus 36. After that, okay, they might try and trick you. Remember, whenever you have a square root, you should check for an extraneous solution. How much faster was the tidal wave traveling after 1 hour than 3 hours? To the nearest mile per hour? The speed is calculated by taking the square root of t minus 2t plus, is it 6? Yeah, plus 6. This gives you the speed. 1 hour, when time is 1 hour, versus when time is 3 hours. You need to plug those in, okay? There is only one area where I think they're trying to trick you here, but that's really just you reading the problem, and I will tell you in 1 minute. So let's say t equals 1 and t equals 3. Okay, let's figure out what both those speeds would be. That would be, okay, the square root of 1 minus 2 times 1 plus 6. Okay, the square root of 1, let's extend this, it's 1 minus 2 plus 6. That's going to be 5. Okay, s is 5. Let's take a look at when t is 3. It's the square root of 3 minus 2 times 3 plus 6. Well, that's the square root of 3 minus 6 plus 6, because that's minus 6. These cancel. It's the square root of 3, and they want to know how much faster, okay, to the nearest mile per hour. So I'm going to round, so it's going to be decimals. I'm going to actually take the square root of 3 and figure out what that is. It's 1.7, is it 2.3 or 3.2? Come on, mine. There you go. The square root of 3 is 1.732, let's call it. Yeah, 1.732. So that is approximately 1.732. So that's going to equal my s here, all right? Here is the one place, if you weren't reading, you might get tripped up here. S is not in miles per hour. That's in hundreds of miles per hour. That's the one place. So this isn't 5, this is 500 miles per hour. Okay? I got to multiply this times 102, and so that's 173 miles per hour. That's not 1.732 miles per hour. It's 173 miles per hour. So they want to know the difference. How much faster, okay, how much faster Was the tidal wave traveling after 1 hour? Oh, wow. After 1 hour than it was after 3 hours. But just subtract the two. 500 minus 173. Oh, my God. 327 miles per hour faster. Oh, my goodness. For a 6-point question, that was easy. All right. Again, the factoring of the quadratic up here I can get. It might have taken you a second, but you could have done that. And that's it. Justify your answer means the work. You did the work. There you go. Boom. We are done. Thanks for hanging with me through this whole exam. I think the part ones, I think the multiple choice, some of those answers to me were tougher, and the short answer parts to me, again, were easier in this one. All right. If there is time permitting, I will do the January 2017, excuse me, the June 2017. Yeah, I'm going to do the June 2017 exam next. And then I'm going to do the June 2018 exam after that, if there's time. I don't know if there will be this school year, because we are about to take the June 2019 exam. And why not do the previous 2 June exams? All right. Hey, keep on studying. Keep on top of your game. Keep on doing more math problems because they all seem to look similar after a while. It doesn't feel that way, but the more math you do, the more confident you will become and the better you will score on these exams. See ya.